1921, Ann Arbor, Michigan. A boy is born by the name Arthur Allen Hoag, who, from a young age, had a keen interest in the stars that led him to pursue a bachelor's degree in physics at Brown University during the height of World War II. After graduating in 1941, he worked at the Naval Ordnance Laboratory working on subsurface weaponry until the end of the war. Afterward, he began studying at Harvard University, where he would eventually graduate with a PhD in astronomy. It was his time here in graduate school at Harvard that he would make an unusual discovery. The year is 1950. Hoag, a budding graduate student, is observing the Serpens constellation and notices something strange. A peculiar object with a bright center and a ring-like cluster surrounding it, a shape that eluded the young graduate student and sparked inquiry. An object he didn't realize at the time would be his most famous discovery, an object that was approximately 612.8 million light-years away, measuring 148,000 light-years across, with the principal galaxy's catalog designation 54559, that he would end up naming Hoag's object. Hoag's initial hypothesis was that the object was a perfectly symmetrical planetary nebula. He quickly disregarded this hypothesis and believed that it must be a type of galaxy. To explain the strange shape of the object, Arthur believed that the object could be explained by gravitational lensing. That is to say that the object he was observing as a singular one was actually two, a faraway galaxy and a nearer, very bright, very massive object that was distorting the light from the background galaxy with its massive gravitational field. His theory would perfectly explain the shape of the galaxy as a simple phenomena of light, and for the following 24 years, that's how it would remain. Fast forward to 1974, and researchers O'Connell, Scargill, and Sargent confirmed the nature of Hoag's object, understanding it to be a type of galaxy. They calculated the amount of mass needed to generate that much gravitational lensing and found that it would need to be abnormally massive to create such an effect. They then measured the amount of redshift in the light of both the inner shape of the galaxy and the outer ring-like structure. They observed that the amount of redshift was the same, and therefore both the ring and the inner structure were actually interacting with each other as a singular galaxy. What they had deduced was that Hoag had not only found a strange object, but the rarest type of galaxy found in the universe, a galaxy until now unknown in the field of astronomy. A ring galaxy. With the launch of the Hubble telescope in 1990, we were finally able to see clear images of these ring galaxies, only to realize how strange they really were. In an article for Big Think entitled Ring Galaxies, the Rarest in the Universe Finally Explained, astrophysicist Dr. Ethan Siegel notes that when looking at Hoag's object, it can be observed that there are a few distinctive features that distinguishes a ring galaxy from any other. First being that the center of the galaxies are composed mostly of older red stars with little activity or new star formation. Second, that immediately surrounding the central core, there are almost no stars, no light, and very little activity at all. And third, that surrounding the gap is another population of young blue stars, indicating that the stars that form the ring of the galaxy are primarily young, hotter, shorter-lived stars. After decades of observing hundreds of ring galaxies at various stages of formation, the leading theories on how these mysterious galaxies came to be is becoming clearer. 500 million light-years from Earth lies a newly forming ring galaxy, located in the constellation Sculptor. The intricate structure was dubbed the Cartwheel galaxy because of its wheel-like spokes that are emerging from the center, connecting the outer ring to the central core. Unfortunately, due to the amount of cosmic dust between Earth and the galaxy, Hubble lacked the ability to capture a clearer image for analysis. That is until 2022, when the James Webb Telescope launched with a powerful infrared telescope that allowed it to achieve much clearer images of the faraway Cartwheel galaxy. These clearer images of its intricate shape help to finally understand how exactly ring galaxies may form. The current theory being that the Cartwheel galaxy's shape was that of any other spiral galaxy, not unlike the Milky Way, until one of the galaxies pictured on the left collided with it some 440 million years ago, passing through the center of it like a bullseye. This then caused the intricate shapes of stars to form the bright ring that surrounds the galaxy. By looking at the spoke-like formation of dust in the Cartwheel galaxy, scientists were able to conceive of and deduce how these galactic collisions may form ring galaxies. That over time these young rings will stabilize into the rare, unusual shape that perplexed the young undergraduate Arthur Hoag in 1950. It is with this history, and many others in the field of astronomy, that we can see what can come from ingenuity, curiosity, and continually asking questions. With continued advancements in imaging, physics, and space travel, we will continue to create a clearer image of the stars above us, far beyond what any of our ancestors could have ever imagined, looking up into the night and crafting stories of animals, myths, and gods in the aeons of our collective history.